and angular speed. This, you can obviously read this for yourself, but let me just explain it this way. If you think about a car has wheels that spin, and it also travels distance linearly. So if you want to know how fast the car travels linearly, one thing you could do is if you knew how many times that tire spun and you knew how far around the tire there was, you could multiply them to get the distance. That's what this is saying here. If you take the arc length and divide it by your time, you would get how fast it's moving per second. Now, the same is true for angular speed. Now, angular speed wouldn't be talking about how far is the car moving, it'd be talking about how fast is the tire turning. For example, if you had little bitty tires, they would turn faster as they travel the same distance as, like, say, a tractor with huge tires. The tires wouldn't have to spin as fast to move the same distance. The formulas are given here. You'll see they are very, very similar. Just remember, S is the same thing as r theta. So this is the same thing as the linear velocity is r theta divided by t. Notice the only thing different is that this one's multiplied by the radius. Let's look at some examples. So old record, it says typical vinyl record has a diameter of 30 centimeters. Okay, that, remember, diameter is the distance from one side of the circle to the other. When played on a turntable, the record spins at 33 and a third revolutions per minute. Now, it's telling you how fast it spins. That would be the W, or the angular speed. Now, that's talking about how far or how quickly it turns around the player. Now, when it says find the angular speed, now it says do it in radians per minute. Now, so what's the difference? Well, let's think about this. In a circle, if you went one revolution, how many radians did you travel? Well, you went 2 pi radians. If it were in degrees, you would have gone 360. So if this thing is making 33 revolutions per minute, then that means 33 and a third, revolutions is going to be, what you would do to find it in radians is I would multiply, and if I need to cancel revolutions, I put revolutions on the bottom, which means one revolution is the same thing as 2 pi in radians. The revolutions cancel out, and so you basically just multiply it by 2. So we'd have that this is 66 and 2/3 pi radians per minute. Now that is our angular speed. That's our W. All right, so now it says round this to the nearest tenth. So if I wanted to round to the nearest tenth, I would just need to multiply this by pi. So we'll go to the calculator, and we would say 66 and 2/3, which is the same thing as 0.67 times pi is 209.449. So the nearest tenth is 209.4. So, oops, our answer here, it would be the same thing as 209.4 radians per minute. That's another way of writing that. Let me check the calculator. Was it 209.4? Yep, 209.4 radians per minute. That's another way of doing that. So that's the W. Now it says a typical vinyl record has a diameter of 30 centimeters, just like all this information is the same. It says find the linear speed at the outer edge of the record as it spins in centimeters per second. So we just found out how fast this goes around per minute on this problem. We found per minute. That's how far it goes around. They gave us the W, and remember the thing about this one was that W equals theta over t. So if we wanted the theta in seconds, because that's what they asked in the next one, if we wanted it in seconds, we would take that same value. So remember we had that W equals 209.4 radians per minute. If I wanted to get rid of the minutes, I would need to find out how fast this is spinning per second. So, or to find the angle per second, what I would do is to get rid of those minutes, I would just come back and I would divide the value by 60 because I want to shrink it down to seconds here, and it'd be fewer. This would be a smaller number. So if I divide this by 60, I should come up with what my angle actually is. So we take that value that we previously got. I'm going to divide this by 60. And I get 3.49 radians per second, or about 3.5 radians per second. Because what I did here is I said in 1 minute, there are 60 seconds. So that's why I divided it by 60, because those would cancel out. And so now, that's what the value is per second. Okay? And so now that I know what theta is, now I can find the linear speed, because the formula for that was v equals s over t. And I said earlier that that's the same thing as r theta over t. Well, we know what our r is. It says up here that the diameter is 30 centimeters. If that's the diameter, then the radius is half that, which means 15 centimeters. So I would take 15, I multiply it times this 3.5, and then I would divide it, and this is per 1 second, and over here we want to know per second, so I would divide it by 1 second. So I have this in radians per second, and we would divide it by 1 second. Let's see what we get. So I'm going to take that 15, and I'm going to multiply it times, just so we don't have a rounding error, I'll get this value there. It would be about 52.36. So we're moving at 52.36, which rounds to be 52.4 centimeters per second. That would be the speed of the outer edge of that record. So now I have one for you to try at carousel to find out the angular speed given this information.